Problem 4, we consider two cases when the air glider is turned on. That means there's air going, which means there's almost no friction. And when the glider is off, that means we have some friction. If we consider a distance d that the glider moves, then the work done is going to equal 1/2 the spring constant k times d squared minus 1/2 k times 0. So this is from initial, before it got stretched to a certain distance d. This would be the work done by the spring, and as you can see and expect, it's only dependent on the displacement, which is the change from the initial condition to the final condition. This is the same as the negative of the work that the spring does on the glider. So if this is the work done by the glider, let's denote this by G, then the work done by the spring is going to be minus the work done by the glider, which is minus 1/2 kd squared. And from the work energy theorem, we know that the work is the change in kinetic energy, which is kinetic energy final minus kinetic energy initial. The glider or the spring, when it reaches its final position, it stops. So we know that's 0. So we have minus 1/2 kd squared equals minus 1/2 mv squared. And if we solve for d, notice that the minus 1/2s cancel out. So we get that d equals v times the square root of m over k. We're told that we have a 1.5 meters per second speed. We're told that the mass is 0.1 kilograms and that the spring constant is 20 newtons per meter. And Newton is a kilogram meter per second squared. So this is going to cancel out with nothing but seconds on the top, and that cancels this second, leaving us with meters. And this gives us about 0.106 meter, or 10.6 centimeters. For part B, if the air is turned off, so now there's friction in the system, and that system is now has a coefficient of friction mu 0.47, then we can say that the work done by the friction force is the friction force times the distance that the glider travels times the cosine of the angle between them. And since the glider is moving one way, the friction force would be the opposite way. This angle would be 180. This will give us minus fd and if we remember what f is, this is going to be minus mu times the normal force times d. And if we consider the glider, there's only two forces acting on it, the normal force upward and the weight downward. So Fn minus mg has to equal 0. Fn equals mg. So we can say that the work done by the friction force then is minus mu mg d. And now we have the work done is the change in kinetic energy. So kinetic energy final minus kinetic energy initial. We have the force of friction work, which is minus mu mg d. Then we have the work done by the spring. Again, it reaches a final position that stops, so this is minus 1/2 m v initial squared. So this means that 1/2 kd squared minus mu plus mu mgd minus 1/2 mv initial squared has to equal 0. And you notice this is a quadratic formula for d. So we use the quadratic formula to solve for d. And we get that d equals minus mu mg plus or minus the square root of mu mg quantity squared minus 4 1 over 2k times minus 1 over 2 mv initial squared all over 2 times 1/2 k and then this gives us that d equals minus mu mg over k plus or minus the square root of mu mg squared plus mv initial squared all over. Okay? And so we can say, plug in these values and get the following: minus mu 0.47. The mass is 0.1 kilogram. G is 9.8 meters per second squared. K is 20 grams per meter, plus or minus square root 0.47 times 0.1 kilogram times 9.8 meters per second squared. The whole thing squared plus 0.1 kilogram. Initial velocity is 1.5 meters per second. Squared all over k, which is 20 meters per meter. This gives us negative 0.02303 meters plus or minus the square root of 0.02303 meters squared, meters quantity squared plus 0.0125 meters squared. Or they will give us two values, d1 equals 0.0 6 meters, d2 equals negative 0.132 meters. We can only have a positive because we know that the glider is only moving in one direction. And we're told that it's a positive direction, so the only direction we can have is d equals 0.086 meters, which is the same as 8.675.